Alright, in this video we're going to look at how to do linear regression using the Desmos calculator. So we're going to work off of this table of values here, and you'll notice that the first thing that we did was we changed the years to a new variable t, which we're calling years after 1989, and that way these numbers become much more reasonable in size. So we're going to work off of these values, so now we're going to switch over to the Desmos calculator. And the first thing we need to do is put in the data. So to do that, we'll click the little plus button here and choose table. Now you can leave these as x1 and y1 if you want, but I'm going to go ahead and call them t and c, since those were the variables in the original document I was looking at. So I'm going to add, oops, that was supposed to be a 3, 5, 7, and 11. So I'm just typing in the data from the question that I was looking at. Oops. All right. And now we have our data in there. Now if you wanted to see what the data actually looks like, we could adjust our graph to let us see it. Notice my values here are going up to about 15,000, so I would need to adjust my y range to at least 16,000, and it looks like my x's are big enough. So there we go, there is my data, and we can see that while not perfectly linear, it looks kind of linear in shape. So now we want to do the regression. The way we do that in Desmos is we write what looks like an equation, but instead of an equal sign, we're going to use the tilde key. That's the one that's usually in the upper right-hand corner of your keyboard. And we're going to write it with the form of the equation we want. So we're expecting this to be a line, right? Normally that'd be y equals mx plus b, but in this case, c is my output variable, and t is my input variable. So I'm going to say c tilde m times t plus b. So I'm writing the equation of a line, mx plus b, but using t as the input variable, c as the output variable, and the tilde says do a regression. In other words, find an equation that best fits the data. And here we go. Here is my results. So here are the correlation coefficients. So r is 0.92. That gives us an indication of how well the line fits the data. And then here is the slope and the intercept, the values for m and b in my equation. And we can see here how well the line fits the data.